Have you ever gone on a hike and just constantly slipped over because your shoes are slippery? Or have you ever have a problem deciding which forest you want to go on a hike in? These problems will go away with our new smart shoe, Terra. Pain points from 10,000 plus reviews. When we began this project, we started by analyzing over 12,000 hiking shoe reviews from Amazon and REI. Two common issues stood out immediately. First, 38% of users complained about poor grip, especially on wet surfaces. Second, 24% said their shoes weren't truly waterproof, leading to wet feet and slipping risks. These numbers were surprisingly high and clearly pointed to the fact that existing hiking shoes are not addressing fundamental safety needs. We then looked into academic studies to understand real-world injuries. According to a 2019 study in Wilderness and Environmental Medicine, 46% of hiking accidents are caused by slipping and falling. Even more concerning, 74% of those slips happen on surfaces like wet rocks, muddy paths, or slick terrain. This shows that hikers are not just uncomfortable, they're actually at risk due to unreliable footwear.
In addition to slipping, ankle sprains are extremely common. The American College of Foot and Ankle Surgeons reports that around 25,000 Americans sprain an ankle every single day. The leading cause? Walking on uneven surfaces, exactly the type of terrain hikers face constantly. This reinforced our belief that there's a major opportunity to improve hiker safety. We also collected insights from outdoor forums. People repeatedly mention shoes slipping even though they have tread, fatigue during long trails, and ankle injuries from lack of proper support. These are issues that current designs simply don't solve well. Our target audience are hikers and all adventurers who need a shoe that can walk on any surface they face in the wild, and are also interested in new features like the automatic sole switching feature. This shoe is for hikers who often face difficult trails and worry about slipping and falling.
To solve these pain points, we propose a smart hiking shoe with an adaptive sole and a connected mobile application. The shoe detects the type of surface in real time, adjusts its sole accordingly, connects via Bluetooth Low Energy, and lets users access trail information from other hikers. It's a combination of hardware, software, and safety-focused features. This shoe can be used in all types of hiking trails that include mud, rocks, steep paths, wet ground, and is also usable even in harsh environments such as rain or slippery mud. Hikers need this shoe because natural surfaces are unpredictable and a significant cause of slips and falls. This shoe would also reduce mishaps like stepping incorrectly because the ground is slippery or wet. It will increase your hiking confidence and will enhance the trekking experience without requiring additional equipment. Here's how this shoe works. The shoe's surface recognition sensor detects terrain conditions in real time. An MCU with edge computing processes data quickly inside the shoe, eliminating the need for an internet connection. The sole automatically adjusts its grip, or the user can regulate it via a mobile app. The shoe communicates with the app via Bluetooth Low Energy to display battery status, switch sole modes, and sync data. The power system combines a thin battery, wireless charging, and TENG, which generates extra energy while walking. The software uses data from Google Maps to help users find forests or hiking paths that have been evaluated by others.
These are our SMART goals. Specific, we're building a shoe that senses terrain in real time, automatically adjusts outsole patterns for firm ground, soft ground, or indoors, and shows live data, surface type, and battery in the app. The app also lets you search trails, pin locations, and read reviews. Power comes from a long-lasting battery boosted by a Ting energy harvester. Measurable, we aim for 200 users to report at least a 50% drop in slipping risk. BLE connectivity and outsole mode switching should hit 95% stability. After field testing, 85% of 150 testers should feel more confident. Within 12 months, we target 10,000 app users and 3,000 trail reviews. The battery should run 18 hours continuously and still keep 20% after 200 kilometers of testing. Achievable, every component is feasible today. Surface recognition and IMU pressure sensors, an adaptive sole mechanism, BLE with an MCU for edge computing, and team energy from walking. Relevant, we're solving real pains. Poor surface grip, slips causing nearly half of hiking accidents, and the need for reliable trail info and confidence on any terrain. Hikers want footwear that adapts and integrates smart features. Time-based, the full system will be functional and field-tested within 12 months. That's our path from concept to confident steps. This slide summarizes our value proposition. Hikers want safety, confidence, and access to reliable trail information. Their pain points include slipping on wet or steep surfaces, not knowing whether a trail is safe, and uncertainty about shoe performance on rough terrain. Our product relieves these pains by automatically adjusting the sole grip, offering real-time terrain analysis, and providing a platform for trail reviews. The gains include safer steps across all terrains, the ability to discover new trails, and long-lasting battery life thanks to Ting energy harvesting. This combination creates a complete solution that no traditional hiking shoe can offer.
Let's move on to the shoe structure. We added an anti-leach system. It uses an inner neoprene seal and an outer elastic gaiter, forming a dual barrier that prevents leeches from entering the shoe even in wet environments. Next, the upper uses 1000D Cordura with PU coating, making it water-resistant, abrasion-resistant, and 99% leach-proof, extremely useful in deep forest environments. TPU overlays reinforce high wear areas. This design ensures durability against branches, rocks, and other obstacles hikers commonly encounter. The shoe also includes a full Gore-Tex 3-layer waterproof membrane for complete protection against water, while maintaining breathability. Inside, a quick-dry tricot lining keeps the foot comfortable and odor-free. There's also a dual anti-leach ankle seal made from neoprene and elastic gaiter materials, preventing leeches or mud from entering the shoe, a critical feature for Southeast Asian hiking environments. The gusseted waterproof tongue prevents water from entering the shoe while maintaining its structure even when wet. The thermoformed TPU toe cap protects the toes from impacts and adds extra stability. Paracord 550 laces and stainless steel hooks ensure durability and strength, especially for long treks. Here's how the smart shoe processes information. It starts with user input, whether you're walking, running, or switching terrains, and any manual mode changes from the app. That input is captured by a sensor array tracking pressure, motion, temperature, and foot impact. All collected data is processed by the microcontroller, which runs logic, safety protocols, and communicates at the app and actuators. Next, the AI Fusion engine analyzes the environment, classifies the terrain, and decides whether adjustments are needed. These changes are executed through the actuation system, which can modify the shoe's stiffness, height, or tread texture. Finally, the adaptive sole adjusts itself and sends a feedback report to the user, completing the smart loop.
Now, let's look at how this system powers itself and connects. The shoe generates energy through a triboelectric generator, capturing power from movement. That energy is stored in a flexible graphene battery, which powers all sensors and systems. And through Bluetooth Low Energy, the shoe connects to the app where users can check system status, update firmware, and control modes. These shoes feature an adaptive sole system with 3 layers: firm ground, soft ground, and indoor. The shoe can detect terrain automatically and switch modes on its own. But users can also adjust modes manually through the mobile app. The app provides shoe matching, battery level monitoring, and system information. This shoe can be connected to your phone through Bluetooth. Once it's connected to our app, you can manually switch between 3 layers of our soles through our app, and the app also shows battery status. Our app includes a built-in search engine that helps hikers choose where to go. Users can filter forests and trails based on difficulty, environment, or reviews. People can also leave their own reviews after visiting a location. This creates a community-driven platform that helps beginners and experienced hikers alike plan safer and more enjoyable trips. These are the 3 sole layers used in our adaptive shoe design. The first layer is firm ground. This sole is ideal for natural grass and hard terrain. It uses short studs that provide grip, stability, and quick movement. The second layer is soft ground. This is for wet or soft terrain, like muddy ground or wet grass. It has longer studs that dig deeper into the surface to prevent slipping. The final layer is the indoor sole. This flat, smooth surface is perfect for indoor environments, such as concrete or asphalt. With these 3 layers, our adaptive sole system can support hikers in almost any environment, providing customized traction whether indoors or outdoors.
This is all the advanced sensor system integrated into our smart hiking shoes. The shoe contains several sensor chips that track pressure, weight distribution, foot movement, and temperature. All of this data is processed by the MCU inside the shoe and then sent to the app through Bluetooth Low Energy. Next, one of the key technologies is the All-Surface Recognition module, which uses AI and sensor fusion to identify the terrain, whether it's soil, rocks, sand, mud, or pavement. The shoe then uses this information to adjust support or provide recommendations inside the app. At the center of all this is the MCU, the microcontroller that acts as the brain. It handles AI processing, data management, and communication with the app. And the entire system is powered by a thin, flexible graphene or lithium battery. It's designed to bend and handle pressure, which makes it perfect for outdoor hiking conditions. All of these components work together to make hiking safer, smarter, and more intuitive. Next one is how we generate power just by walking. We use Tang technology. Tang is a technology that converts simple physical movement like pressure, friction, and bending into usable electrical energy. It works using the triboelectric effect, which is the same phenomenon that causes a balloon to stick to your hair after you rub it. Every time the user takes a step, the pressure compresses multiple Tang layers. As these layers move against each other, friction occurs between 2 materials that have different electrical properties. This friction generates electric charges, which are then collected by electrodes and stored in a small circuit or the shoe's battery. Let's move on to our demo.
Not every trail is built the same, and not every shoe reacts like this one. We believe the best hiking shoe doesn't just support you, it understands you. Terra shoes, walk smart into the wild. The first hiking footwear powered by real-time adaptive technology, an AI-powered sole that adapts to every terrain automatically. Firm ground, soft ground, flat surface. Studs extend and retract, grip changes in seconds. Your steps stay solid always. Smart sensors read the surface and respond instantly. Terra learns, adapts, then powers itself as you walk.
So you can connect Terra application to your phone. Full control in your hand. You can find and pair your shoes. Switch between auto, firm, soft, indoor, manually deploy or retract the outsole studs. Monitor battery and system status in real time. Looking for the right forest? Let Terra help. Filter trails by difficulty. Read real reviews. Plan like a pro. Every step is power. Every trail is yours to conquer.
Terra, walk smart into the wild.
And this is what our app looks like. We decided to give our app a more natural vibe since it's a hiking shoe. So the main color would be green and black. From our survey of 9 people, here are the key points. The most requested was heating and cooling control. 3 respondents want temperature adjustable shoes for all season use. 1 person highlighted shock absorption and traction, noting the need for better cushioning and faster drying materials. 2 respondents liked the idea of shoe connectivity, saying group tracking could help prevent people from getting separated. Another 2 people were interested in an adaptive sole that adjusts to different surfaces, seeing it as a new and promising idea. And one respondent suggested adding a comfort or pain relief feature to reduce foot pain during long hikes. Overall, these insights show which features users find most useful and innovative. These are all the members of our group. Thank you for your attention.